Hey, math fans, welcome to section 4.2. We're on day 5. Let's get started. Many laboratory experiments use a design like the one in the online SAT course example in your book. Experimental units lead to treatment, lead to a measured response. However, when you are outside the lab, badly designed experiments can often yield worthless results because of confounding. Too many other variables might be doing the explaining for why something might be responding the way it is. So how do you experiment well? Well, what you need to have is a random assignment of treatment. So you can have a comparison between the two groups or three groups that you're looking at. Otherwise, bias might creep in there. In an experiment, random assignment means that the experimental units are assigned to treatments using a chance process. Let's take a look at the classroom temperature example. Remember, I had a classroom full of students, and some of the students were placed into an 82-degree temperature room, and some of them were in a 72-degree temperature room, and I looked at the test scores. However, there was probably a lot of different things going on between the two groups. However, if I take everybody that's in the class and I ask them to write their name down on a slip of paper and put it into a hat, and then I pull out people's names, which is a random chance process, and half of the group gets put into the treatment group, and half is either my control group or it's a second treatment. But a lot of times you'll see the word control come up. Half are placed into this group. Then chances are I'm going to have some high level and some low level students in both groups. I'm going to have students that had a great breakfast before they came to school, and I'm going to have students that might have not have eaten anything. I'm going to have students that had a great night's sleep, and I'll have students that really didn't get a good night's sleep, but they'll be in both groups because it was a chance process to determine which people went into which group. I'll have high and low in each of these groups, so we can kind of rule out those potential confounding variables and really look at, does temperature cause test scores to either rise or fall? Here are the principles of experimental design. The basic principles are: 1, comparison. You need to be comparing at least two groups, two or more treatments. We're trying to see, does this cause this to happen? So you need to have a comparison. How does that happen the best? It's through a random assignment of treatment. There's that word again, a random assignment of treatment. Okay? Doing this creates roughly equivalent groups of experimental units. It balances the effects of other variables. Control, that keeps other variables that might affect the response. It keeps it the same for all the groups. And then finally is replication. You don't want to do an experiment just once, because here again, maybe that chance process that you used wasn't, so random. The more you do it, the more experiments that you run, the better it is to see if A really causes B to happen. I love this graphic. It shows a completely randomized design. By the way, that's a vocabulary word. You should write that down. In a completely randomized design, you start with your experimental units. In this case, my example was you've got your classroom full of students, and you use some sort of chance process. And I gave you the example of putting people's names on a slip of paper into a hat, or you could use a random number generator, or flip a coin, or roll a die. But the point is that Some people are going to go into group 1 due to this chance process, and some people are going to go into group 2. Now, it doesn't have to just be 2. It could be 3. It could be 4. I could have several different rooms at several different temperatures, and I could compare them all, but it's got to be a random assignment to those groups. And the treatments, as we said before, that's where we get to test our explanatory variable. In this case, it's temperature, the temperature of the room. And then we can measure our response variable and compare the results. And we'll see what is the, average score on each of these exams. Let's walk through some examples here that the book provides. Does caffeine affect pulse rates? Some of you that drink coffee are probably like, yeah, it does. But this problem says, suppose you have a class of 30 students who volunteer to be subjects in the caffeine experiment. Explain how you would randomly assign 15 students to each of the 2 treatment groups. Remember, when you're doing this problem, make sure that you're very detailed and very specific. How would you number them? What buttons would you push using technology? Using table D, what happens if you get a number that repeats in the table? You have to mention all of those things. Here's the answer. Take a moment to pause the video and see how thorough they are in their answer. Notice how very specific they are. Writing A on 15 of the slips of paper and B on the other 15. Part B with the technology, mentioning the number they would push on the calculator. How would you number them in the very beginning? Using the random number table. And then saying that I'll go 2 digits, moving left to right. That's very specific, and you want to be very specific on the AP test when you're trying to describe something like this. Here's another example. Read through it. Try it on your own. It says, explain how each of the 4 principles of the experimental design could be used in this multitasking study. And here's the solution to that problem. Again, make sure you address each of these principles. How were the 2 treatments compared? How did they use random assignment? How did they control? And what was the replication that they used? And that'll do it for day 5. Join us next time for day 6.